Greetings from the World Ethanol Biofuels Conference in Brussels. I'm joined by Scott Kohl from White Energy. How are you doing, Scott?
I'm doing good.
If you look at the past 5 years in ethanol production, what are the most important advancements you've seen?
In the past 5 years, we have seen tremendous improvement in yeast technology. Yeasts today can make enzyme, glucoamylase. They have higher yields because of metabolic pathway shifts, either genetically enhanced or naturally they were better base strains. That's probably the biggest change in the past, I would say, 2 to 3 years. And if you go back to 5 years, the advances in enzyme technology has been striking as well. We have lower pH tolerant enzymes, which increases both the yield at the plants as well as reduces nitrogen loss and does a better conversion of starch to ethanol. And then we've also seen advantages in mechanical processing that allow for higher fermentation yields through processes like selective grind technology, selective milling technology, processes that are basically borrowed or adapted from wet milling into the fuel ethanol plants.
And we've heard a lot about cellulosic ethanol in the previous sessions. I'm wondering, if there's to be a breakthrough with cellulosic ethanol, where would it come from? Would it come from something like an enzyme breakthrough, through a physical process in a plant? Where do you see that happening?
My opinion is for ethanol from cellulose to really become part of our production, we really have to go after the fibers naturally present in the grain, corn as an example. If you look at all the hurdles to make ethanol from cellulose, many of the hurdles don't exist for corn kernel fiber because you already own it. When you buy the corn, you already have good quality control. There's no shipping to do. It's already there, and you already have an ethanol plant there. So I think my feeling is the enzymatic route will be the most successful there, but it doesn't have to be. It can be a chemical route to make the sugar for fermentation. But I really think that if we can't do grain fibers, whether it's wheat fiber or corn fiber or sorghum fiber at the plant, doing it from harder to process materials like stovers and straws will be less successful. I think once we're successful on fiber conversion in the plant, we can then take that learning to corn stovers and wheat straws and such.
And if you look at the processes used in White Energy's ethanol plants, are they different in some way from other ethanol producers in the US and elsewhere?
They're really similar. I mean, every plant has a little bit different thing they do, but they're really, for the most part, pretty trivial in the grand scheme of things. The only thing that White Energy really does different is we have a hybrid fermentation process where it's a cross between a batch process and a continuous process. Otherwise, the technologies that we have or the processes that we use are used elsewhere in the industry, maybe often.
You're also speaking at the Distillers Grain Summit on Thursday, I think I'm right in saying. How can fractionation be used to increase the value of the co-products that come from ethanol production?
So distillers grains as an aggregate are not really a great feed for any animal segment. It has too much protein for cattle, it has too much fiber for swine and for poultry, it has too much fat for too much fat for swine and too much fat for dairy. So as a mix, it's just a cheap feed. It's good, but it's not great. If we can pull it apart and concentrate the protein in one container, or one bucket if you will, and leave the fiber behind another one, the fiber is great for cattle. They digest it very well. And so they will do well on that feed. And then the higher protein that's depleted in fiber would be a great feed for chickens and swine. So you're basically taking a material that is not really well suited for any animal and breaking it into the components that make it valuable for both species. And for the chicken and swine, you minimize a manure problem. So if the cellulose are a third fiber, you have a tremendous amount of manure for poultry in swine that is a detriment, whereas for the cattle, the protein's too high and the fat's too high. So separating the distillers into an oil-rich or 100% oil fraction, a protein-rich fraction, and a fiber-rich fraction make a better feed for animals and command higher prices. So the ethanol industry will make more money on it, and the animal feeding industry will have better feeds to use in their operations and make more money as well. It's a win for everybody.
Excellent. Thanks very much for your time, Scott.